Okay, we're going to start Chapter 7 now. Chapter 7 is all about integration, how to do lots and lots of different kinds of hard integrals. So there will be lots and lots of techniques. This first one is called integration by parts. And it's a rule for how to take the integral of certain types of products. Just like the chain rule for derivatives is what let us develop the U substitution method for doing some integrals, the product rule for derivatives, it's what's going to let us develop the integration by parts method for doing some integrals. So here's what I mean. Here's the product rule for derivatives, right? The derivative of a product is equal to fg prime plus f prime g, or however you like to say your product rule, but this is the statement of the product rule. And what I want to do is integrate both sides of this with respect to x. So that means I need to draw an integral sign and a dx on both sides. And that's a little messy. Let me rewrite it. On the left, I have the integral of the derivative of fg. Well, the integral of a derivative just gets you back where you were, so that's just fg. And on the right, I have, I'm going to split that up as two integrals. The integral of fg prime plus the integral of g f prime, both with respect to x. But now what I want to do is rearrange that so that I solve for that middle thing, the integral of f times g prime dx. So I'll subtract the other integral and I'll rewrite it. The integral of f times g prime with respect to x is equal to f times g minus the integral of g times f prime with respect to x. This is the rule or the formula for integration by parts. So it tells you how to do the integral of a function times the derivative of something else, f times g prime. But you'll notice that the rule just ends up making you do a different integral instead. So if you want to do the integral of fg prime and you're not sure how, this rule lets you turn it into fg minus the integral of g f prime, and you have to hope that that one is something you can do. I want to write this another way. This is the full version, right? Instead of f and g, I'm writing f of x and g of x. So the integral of f of x, g prime of x, dx equals f of x, g of x minus the integral of g of x, f prime of x, dx. That's exciting. That's just what I had on the other page. But now I want to rewrite it, and to do that I'm going to give f and g new names. So I will call f of x u and g of x v. Then just like with u substitution, I can figure out what du is. It's f prime of x dx, right? You take the derivative and stick a dx on. Same thing with v. dv is g prime of x dx. So now I want to rewrite the equation in black there. Anytime I see f of x, I'll write u. Anytime I see g prime of x dx, I'll write dv. Anytime I see f prime of x dx, I'll write du. And anytime I see g of x, I'll write v. So the left-hand side is u, f of x, times dv, g prime of x dx, and the integral of that. On the right-hand side, I have f of x, g of x, and that's uv, minus another integral, and this integral is of g of x, f prime of x dx, so that's v du. This is the same formula as the previous one. This is just written differently, and I think it's easier to remember. So the way I remember the integration by parts formula is the integral of u dv equals uv minus the integral of v du. So how do you use this? Let's do an example. I'd like to take the integral of x sine x with respect to x. So realize that this means I'm looking for a function whose derivative is x times sine x. I'm going to call x u, and I'm going to call sine x dx dv. Your dv will always contain a dx as part of it, or d, whatever variable you've got. Okay. So this is how I like to organize things. You can do it a different way, but u equals x, that's what I just decided, and dv equals sine x dx, that's what I just decided. Well, if u equals x, I can take the derivative and get du equals dx. Now I know dv, and so I want to find v. So I have to go backwards and say I know what dv is, I know what the derivative is, what was the original. So if dv is sine x, the original function, v, was negative cosine x, right? Basically what you're doing is you're writing down an antiderivative of dv and calling it v. So right there you have to do a little tiny integral, even just in the setup. a little antiderivative. Okay, but now I know all four of my things, u, du, v, and dv. And so I can use the formula. My integral of x sine x dx, that's the integral of u dv. And the formula for integration by parts says that's equal to uv minus the integral of v du. So I just fill in what those things are. uv is x times negative cosine x, so that's negative x cosine x, minus the integral of v du is the integral of negative cosine x times dx. Well, minus an integral of negative cosine I can just rewrite as plus the integral of cosine. Minus a negative is plus. And then I know what the integral of cosine x is. It's sine x plus a constant. Remember, no matter what else happens, when you do an indefinite integral, an antiderivative, you need to end up with plus a constant. Okay, so there's my answer. How do I know if it's right? Well, I can check it. I can check it by taking the derivative of that answer and seeing if I get x times sine x. Feel free to pause the video and do that now. It is correct, though. I'll let you know. Okay, so integration by parts lets us turn some integral that may be hard into one that's easier to do or simpler in some way. So integration by parts, which I've written IBP, the goal is to take the integral you're given and think of it as the integral of u dv in such a way that the integral of v du is simpler. Now that doesn't mean it's going to be super easy. The simpler integral still might need to do integration by parts again, or it still might need the u substitution to do that integral, or one of the other techniques that we will be learning later. Okay? But hopefully it's something you can do. There's a little bit of a, I guess, mnemonic to help you remember a good strategy for choosing what's u and what's dv if you're using integration by parts. It's not a guaranteed that this will work, but it's usually right. And this is LIATE, which liat or liate or liati, I don't know how you want to pronounce that, but LIATE. And this tells you what are good things to choose for u. So the best thing is a log function. If you've got a log function there, let that be equal to u. If you don't have a log but you have an inverse trig, pick that for u. If you don't have one of those but you've got something algebraic in your product, like a polynomial or a square root of x or something, that's a good third choice. Trig functions are next in the hierarchy, and finally exponential functions. So we're kind of going down, right? You want u to be the first one of these that exists in your integral, and then dv is the rest. So there are lots of examples in the book. I recommend that you read some of them. I'm going to show you one example because it's something that comes up very occasionally, and it's a little tricky. This is several steps up in difficulty from the example we just did. So it might be good to stop the video, read some of the examples in the book, and then come back. But you can just keep watching. Just don't panic if this seems too complicated. Okay, so we want to take the integral of e to the x cosine x with respect to x. That is, I want to find a function whose derivative is e to the x cosine x. Well, according to my LIATE thing, trig is the first one of those that's here in this integral, right? Trig comes before exponential. So u is going to be cosine x, and the rest of it, e to the x dx, is going to be my dv. So e to the x dx is dv, and u is cosine x. And then I take the derivative of u to get du is negative sine x dx. And I take the antiderivative of dv to get e to the x is v, right? If dv is e to the x dx, then the antiderivative of that is just e to the x. Here's my formula for integration by parts. So that means the integral of e to the x cosine x dx, and I just write what's there. uv is e to the x times cosine x, and v du is negative e to the x sine x dx. Okay, so this is good. This lets me say the integral I wanted to figure out is equal to this other stuff. But this other stuff contains an integral that I don't know how to do. So I'm going to do integration by parts again. Okay, Again, I have an e to the x and a trig, so the trig gets to be u and the rest of it is dv. And I should point out that the minus go away again. And so I have u is sine x and dv is e to the x dx. So I can find du and dv. Right, so just like before. Now that integral, that second integral, the one in the box there, using integration by parts formula, I can get that that thing is equal to the new u, the new v, minus the integral of the new v, the new du, right? uv minus the integral of v du, but the purple stuff, not the blue stuff. So that's what the box there equals, which means I can fill in the box with this stuff I just got. So I put it together. The original integral I wanted was from the first integration by parts, e to the x cosine x plus this purple stuff, e to the x sine x minus the integral of e to the x cosine x. But hang on, that just got me back where I started. I started off having to do the integral of e to the x cosine x, and I still have to do the integral of e to the x cosine x. It seems like this didn't get me anywhere, but it did. So let's call that integral a name. I like I for integral, right? So each of those is an I term. And I now have an equation that says I equals something minus I. So I'm going to add I to both sides of that equation. That'll move the right hand to minus I over to the left, and I'll have 2I. 2I equals e to the x cosine x plus e to the x sine x. And now I can solve for I. Remember, I is the integral I wanted to find out what it equaled in the first place. So I solve for I, and I get e to the x cosine x plus e to the x sine x, all divided by 2, and I forgot to write plus c. I'm so sorry. But that integral is what I wanted. I wanted the integral of e to the x cosine x. That integral is called I. I found I, so I found the integral I wanted. There are lots of examples in the book. We will be doing lots of examples in class. It'll be fun, but before you come to class, do this video question. The video question is, if you're doing this integral with integration by parts, we pick u to be 3x squared and dv to be the rest of it, sine x dx. What would uv minus the integral of v du look like, right? So what would the integration by parts formula give you? Don't finish it. You don't need to keep going. Just write down what that would look like. Bring it to class, and I will see you there.